Section 1.1, Linear and Absolute Value Equations. In this section, we will learn how to solve linear equations and how to solve absolute value equations. But first, I want to do some definitions. It may have been a while since you've taken an algebra course, so just to review some vocabulary that we'll be using throughout the semester. First definition, variable is a letter representing a quantity that may change. X is a common variable that is used in algebra, but it really can be any letter. Second definition, constant, a fixed value that stands alone. So if we had the expression, which is actually our next definition there, any combination of variables, constants, grouping symbols, and operations. So 4x plus 5 is considered an expression. And in that expression, 5 is a number that stands alone. It does not have a variable behind it, multiplied to it. It just stays 5, it stays constant. So that's what we call the numbers that don't have the variables behind them. So if we did another example, let's say we did x squared minus 3x minus 7, the constant in that would be the negative 7. And fourth definition is term, a single number or variable, or numbers and variables multiplied together. Terms are separated by plus or minus signs. So if we were looking at, again, this expression 4x plus 5, it has two terms. 4x is one term, and 5, it would be your second term. So if you were listing them, they would be 4x, comma, 5 are the terms in that expression. 4x by itself is just one term. Even though there is a number and a variable, because they're multiplied together, it's only one term. To be more than one, you have to have plus or minus signs. So I could multiply A times B times C times D. Multiply all those together, and that is still just one term, since they're all multiplied without any addition or subtraction between them. If I wrote it as A plus B plus C plus D, now that would be 4 terms. Coefficient, a number that is multiplied with the variable. In the expression 4x, 4 is the coefficient, x is the variable. So it is basically the number in front of the variable, and when they're right next to each other, it's understood that they are multiplied. And it could have more than one variable. You might have something like 5xyz. 5 would be the coefficient of that term. Also, we might mention here, sometimes when you just see a variable, like let's say you just had an x, it still has a coefficient, but the coefficient is not visible. There is actually a 1 as the coefficient. It doesn't have to be written there. And the reason is because it's multiplied, and if we did 1 times x, well, that's the same thing as just x. But if I were to give you x and say, what is its coefficient? You would answer 1. Number 6, leading coefficient. This is the number that is multiplied with the variable that has the highest exponent. So look at this next expression. We've got an x to the 8th, to the 4th, and an x squared. Our highest exponent is the 8. And so that makes that whole term there, this whole thing is our leading term. And the coefficient of that term is the 7. So 7 is called the leading coefficient of that whole expression. Even if the terms were not in descending order, with the x to the 8th term first, it still would have a leading coefficient of 7. It's always the number in front of the variable with the highest exponent. Number 7, equation is a math sentence containing an equal sign. What we've looked at so far have been expressions, like we looked at 4x plus 5. Notice that there is no equal sign in that. But if I were to put an equal sign and a number or variable on the other side, now we call this equation. And what makes it an equation is the equal sign. We also want to know what degree is. It is the highest exponent on the variable. So if I were looking at this term, 7x to the 8th, its degree is 8. If I were just looking at 4x, that term, and I wanted to know the degree, well, it's kind of like what we talked about up here. If you don't see the number that is the exponent, it is a 1, because x to the first power is the same thing as just x. So in that case, your degree is 1. This equation would be considered degree 1 because the exponent on the variable is a 1, an invisible 1. So we will be solving equations a lot this semester. And what that means is to find all values of the variable that make the equation true. So if we had something very simple like x plus 2 equals 5, that is a degree 1 equation. We know the solution to that probably off the top of our heads before we've ever learned the steps for solving. We know that if x is 3, this equation becomes a true statement. True is the key word there. If I substitute 3 in place of x, then we get that 5 equals 5, which is true. And this number, 3, is called the solution or the root or 0 of the equation. 3 different words there that basically all mean the same thing. Right now, we're mainly going to call them solutions. Later on in the semester, we will use roots or zeros more often. We'll come back and talk about that again when we get there. Okay, so now this is just a few problems to help reinforce the definitions that we just talked about. So we have 4 different expressions in this table. And in the first column, we are going to write down the leading coefficient. Now, if there's only one term, then you're going to write the coefficient of that term. So for number 1, it would be -7. The degree is the highest exponent on the variable. Remember, if you can't see that exponent, it's a 1. So the degree of this is 1. And these are multiplied together, -7 times x. So that is only one term. There's no addition or subtraction, so it's just one term. Look at number 2. It is again just one single term. There's no addition or subtraction in it. If we want the coefficient, we might actually want to think about writing this a little differently. There's a 1 in front of the x that we don't see. And this is something we didn't really mention when we were going over the definitions, but it could be rewritten as 1/5 times x cubed. Those are the same thing. They mean exactly the same. It's just 2 different ways to write it. So this format here helps us better see the coefficient would be the fraction 1/5. And our highest exponent is 3, so 3 is the degree. Okay, look at example 3. This expression has 4 terms in it. You've got 1, 2, 3, 4. 4 terms. Remember, the plus or minus separate terms. So let's find the term with the highest exponent on it. It happens to be in descending order, so the highest exponent is first, and that number is our degree for the whole expression. So we would say the whole thing is degree 5. We do not add up the degree of each term. We just take the highest of those 4 terms. And if we want our leading coefficient, we're still looking at this n to the 5th term. In front of n, we don't see a number, then it is a 1. So 1 is our leading coefficient. If you had a negative x, by the way, which I didn't put an example of, the leading coefficient of that would be considered negative 1. Okay, look at number 4. It is not in descending order. Here is our term with the highest exponent, and if we look in front of that, we have a negative 4. So negative 4 is our leading coefficient. Our highest exponent is 2. And we have 3 terms. 1, 2, 3. If I asked you to list those terms, they would be 5x, comma, negative 4x squared. Always include the negative if the coefficient's negative. And negative 7. Those are your 3 terms. So we are going to be solving linear equations as our first type of equation to solve. So let's talk about what is a linear equation. It's an equation where the highest exponent of the variable is 1. In other words, that it is an equation that is degree 1. That's how you can define linear equation. The standard form looks like this, where a and b are just representing numbers, but what makes this linear is that its variable has an exponent of 1. It's just x. It's not x squared, it's not x cubed, it's just x. If you had something like x squared plus 4 equals 0, that is not linear because of the exponent of 2. If you had an x cubed, not linear. It has to just be x to the first power. Linear equations have only one solution, and if you graph them, their shape is a line. So let's do this multiple choice question just to re-emphasize what a linear equation is. We are going to pick which one of these would be linear and equation, both. So number 1, or I should say A, has an x squared in it. That eliminates A from being a linear equation. It would be a degree 2 equation. B, well, it has x to the first power. 1's our highest exponent on the variable. It does have an equal sign, so it meets both of those. The x to the first makes it linear. The equal sign makes it an equation. So yes, this is a linear equation. Let's go ahead and look at C and D. C has the exponent of 1 on the variable, but it does not have an equal sign, and that means it's not an equation. And D does have the equal sign, so it is an equation, but its exponent is not a 1, so D is not linear. Okay, I'm going to stop on the video there, and then I'll do a second video where we will actually start solving some equations.